All right, for this example, we're looking at a higher degree polynomial that we'd like to factor or find the zeros of. So in this one, we're going to take 6x to the fourth minus 7x cubed minus 12x squared plus 3x plus 2. And we're going to find possible zeros by using the rational 0, 0. So the first thing is to note which one is our constant. So that's our 2, and then which one is our leading coefficient. So A naught is equal to 2, which means that the values P are going to be plus or minus 1, plus or minus 2. AN is equal to 6, which means that Q is going to be equal plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, and so we're looking for a list of P over Q. So this list of possible zeros. So we'll have plus or minus 1 over plus or minus 1, which is plus or minus 1. We then have plus or minus 2 over plus or minus 1, which is plus or minus 2. Next, we have plus or minus 1 over plus or minus 2, which is plus or minus 1/2. Then plus or minus 2 over plus or minus 2, which is 1, which we already have. So we don't need to write it again. Next, we are going to look at then plus or minus 1 over plus or minus 3, so plus or minus 1/3. Then plus or minus 2 over plus or minus 3, so plus or minus 2/3. Then plus or minus 1 over plus or minus 6, plus or minus 1/6. And then the next one is plus or minus 2 over plus or minus 6, which is actually 1/3, and we have. So that is the list of possible zeros, or rational zeros, I should say. Now to find all the zeros. So starting off with the possible zeros that we have here listed, I'm going to try 1. Now when I do 1, it's simply the coefficients added all up. So 6 minus 7 minus 12 plus 3 plus 2. So you can see that we have 11, positive 11, then with a minus 19. So that's not going to 0. Okay. When I plug in -1, if the power is even, it is the coefficient. If it's odd, it's going to be the opposite sign of the coefficient. So that means 6 plus 7 minus 12 plus or minus 3, then plus 2. Okay, and so looking at that, and that also isn't going to work. Okay, so I'll write these out a bit more just so you can see it. So again, I'm plugging in possible values. So P at 1 is equal to 6 times 1 minus 7 times 1 minus 12 times 1 plus 3 times 1 plus 2. And like I said, that goes to, so that was a 19 minus 11. So that's a positive 8. So it doesn't equal 0. So 1 is not a 0. Okay, it was a possible, but it's actually not. So now we're going to try again with -1. P at -1. 6 times -1. Oh, this was actually, I forgot the powers on it, but it doesn't matter. There we go. So 6 times -1 to the fourth minus 7 times -1 to the third minus 12 times -1 squared, then plus 3 times -1 plus 2. And so this ends up being 6, then plus 7, minus 12, minus 3, then plus 2. Okay. Oh, wait, this one does work. So 6 plus 7 minus 12 minus 3 plus 2 actually does work. I was thinking something else. So you can see this goes to 0. So -1 is a 0. So that means we're going to use it in our synthetic division. So negative 1, and we have, remember, we want to make sure to check it's descending in power, and each power is accounted for. Okay, so we have fourth, third, second, first, and our constant. So 6, negative 7, negative 12, 3, and then 2. Okay, and now we're going to do our synthetic division. So negative 1 times 6 is negative 6, so that's negative 13, so now that's a positive 13. So then that's 1, negative 1, so that's 2, negative 2, 0. Remember, the last number is the remainder. So the degree of the first quotient here, so Q1, is equal to degree of P minus 1. In this case, the degree of the polynomial is a fourth degree polynomial, so that means our quotient here, it's a cubic. Okay, so that's what we're looking at. So the next thing to do is find the zeros for this one. So Q1 is equal to 6x cubed minus 13x squared plus x plus 2. Okay, now whatever didn't work, for the first, when I did this one, that 1, notice it didn't work for the polynomial p of x. It's not going to work for this either. So we can go ahead and skip trying 1 out. These are the possible zeros still. These are the lists of possible zeros. So negative 1 worked. Negative 1 could work again. Okay, so we can always try to see if negative 1 is going to work. So Q1 at negative 1 is going to be then 6 times negative 1 cubed minus 13 times negative 1 squared plus negative 1 plus 2. So this gives me negative 6. This gives me negative 13. This gives me negative 1 plus 2. So that definitely doesn't work. All right. So now we got to try another number from the list from before. So Q1 of, say, now trying 2. So 6 times 2 cubed minus 13 times 2 squared plus 2 plus 2. So this is equal to 6 times 8 minus 13 times 4 plus 4. 48 minus 52 plus 4. That does equal to 0. So that means 2 is a 0 of the polynomial. So 2, and I'm going to have 6, negative 13, 1, and 2. So 6 comes down. So 2 times 6 is 12, so that's negative 1. That's negative 2, and so that's then goes to 0. Okay, so that means that now we have Q2 is equal to 6x squared. So remember, the degree of Q2 is equal to the degree of Q1 minus 1. So this means that we have a third degree minus 1. So now we're going to have quadratic. There we go. So we're going to get a quadratic from this, which means that we have then 6x squared minus x minus 1. Okay. So the idea here is to look for two numbers that, well, this kind of goes backwards, but this is actually factorable. But if you don't see it, I want to go ahead and use the quadratic formula in case you don't see it, because not everyone sees these ones right away. It takes a little time and effort on an exam. If you can't factor something like this, go right ahead into quadratic formula. Okay, but the minute we get it down to a quadratic, then we know we can use those techniques, either completing the square, quadratic formula, or factoring if possible. So for this one, we're going to use the quadratic formula just because. Like I said, it could be factored, but let's assume that we didn't know that. So we're going to have A is equal to 6, B is equal to -1, and C is equal to -1. So x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So this negative b, so negative -1 plus or minus square root of -1 squared minus 4 times 6 times -1 all over 2 times 6. So this is 1 plus or minus square root of 1, and then -4 times -1 is then a positive, so I'm going to have plus, and then 4 times 6 is 24 over 12. So this becomes 1 plus or minus the square root of 25 over 12. And luckily for us, 25 is a perfect square, so it comes out 1 plus or minus 5 over 12. This gives me two answers. Okay, whenever you can, if you can simplify it further, it's not left with a square root sign or a radical, you're going to go ahead and break it down into the two parts. Okay, so we have x is equal to 1 plus 5 over 12, and then we have x is equal to 1 minus 5 over 12. So for this one, 6 over 12, so that's 1/2. For this one, we have then -4 over 12, so that's equal to -1/3. Okay, and so now the zeros of the polynomial, x is equal to -1, 2, 1/2, and -1/3.